This lesson is for Advanced Algebra, Lesson 10.7 on the law of sines. The law of sines is used for non-right triangles. Hopefully you remember that right triangles use what? Right triangles use SOHCAHTOA. So if it's a right triangle, go ahead and figure out if you're going to use sine, cosine, or tangent using SOHCAHTOA. If it's a non-right triangle, you may be using the law of sines to calculate. And you will use the law of sines for finding both missing sides and missing angles. Before we get into the law itself, we need to do a quick review on how to find solutions to a statement like the sine of theta equals 0.528. If we're trying to solve for theta, one of our options is to find the inverse to solve. So if I do the inverse sine on both sides, obviously that would have to be a calculator question because 0.528 is not a value on our unit circle, or it's not one that we've memorized anyway. So when you do the inverse sine of 0.528 on your calculator, making sure that you're in degree mode, theta ends up being 32 degrees approximately. Now if we graph it, I want to show you how there's actually two answers. So let's just do a quick sketch of what the sine graph looks like. Remember that the sine graph starts at 0, goes up, and then comes back down, and then back up. And it crosses at 180 and at 360. So if we try to figure out where that 32 is located, 32 is going to be about a third of the way to the 180. So the 32 is going to be about right here. And so if you draw a line where that 32 would end up crossing, notice that it becomes something that crosses the graph twice. So there's potentially another answer here. So to find that other answer, I want to look at the unit circle for a moment. So let's do a quick review of that. And let's just pretend that this said 30 degrees just for a moment, just to make our calculations a little bit easier. So remember, at 30 degrees, the coordinate there is square root of 3 over 2 for the cosine and 1/2 for the sine, which makes sense. If we were doing the inverse sine of just 0.5 instead of 0.528, we know that theta would be 30 degrees because the sine at 1/2 is that number. But according to our graph here, there should be another answer before we get to the number 180. So if we think about where else the vertical component is going to be the same as what it is here, wouldn't we say that it would be the same over here? If you go up the same amount, whether you're in quadrant 1 or quadrant 2, the y values there are going to be identical to each other. In fact, they're going to be equal to 1/2. It's almost like you've gone halfway up the circle, or halfway to the 1. So what is this value over here? Well, it's going to be a number less than 180. It's going to have the same relationship to the x-axis that this value does. Since this one is 30 degrees away, this one's going to be 30 degrees as well. So if we go to 180 and then take 30 degrees back, we'd be at 150. So there's another answer that's 180 degrees or less than 180 degrees away from the answer that we got. So to find the second answer when you're working with inverse sine, take 180 minus the answer that you got. When you do the inverse sine on the calculator, it's always going to give you the answer in quadrant 1, but inverse sine potentially has two answers, another answer that would be in quadrant 2 that the calculator won't give you. So when you're working with inverse sine to find a missing angle, keep in mind that there is most likely going to be a second answer that you need to find by taking 180 minus the first answer that you got. So then you'd say that the second answer is 148 in this case. And you can see that real clearly here in the graph as well, that there's going to be two of the same answers before you get to 180. We'll revisit this again at the end of the lesson. So we're going to move on now to the law of sines itself. The law of sines is a very simple idea. It's technically three fractions that are set equal to each other, but when we deal with it, we're only going to be using two of those three fractions at a time. Once we've filled in all of the values, we're going to cross multiply to solve, and I'll show you what that means or what that looks like. And when you solve, make sure to keep the bottom number in front of the sign. And again, I'll illustrate that. Keep in mind that you can use this law to find either missing angles or to find missing side lengths. One more thing to explain before we actually give it a try. Notice that the letters here are done intentionally. Capital A is an angle, lowercase a is the side across from that angle. So basically when you're setting up your law of sines, you're going to look for angles and sides that are across from each other, and you're going to turn those into two equal fractions. So that's the basic idea. Let's go ahead and give it a try. Some of the questions that you're going to be given are going to be given to you in word form like this, and you'll have to provide the picture. So simply draw a triangle. It doesn't have to be any particular type of triangle. Go ahead and label it according to what they give you. If you started labeling at a different corner, let's say you started here and labeled that A and then went L and then G, it would still be correct. So know that you're not going to lose points for mislabeling or labeling in a different way from me. Go ahead and fill in the other information that they give you. They say that the measure of angle A is 55, so we're going to fill that in, making sure that the 55 goes wherever you put the A letter. Angle G is going to be 17. And then be careful here, little a is 7, and that has to be in a very specific location. Little a has to be across from angle A. Those go together. So little a has to be here, side LG has to be the side that's labeled with a length of 7. So you would lose points here if you put the 7 in the wrong spot. Now you're going to find little g. Little g is across from big G, so our goal is to find this length here. Now I'm going to go ahead and I'm going to start to find angles and sides that are across from each other, because that's how you set up the law of sines. I usually try to start with a pair that I know both, a pair where I know both the angle and the side across from it. So in this case that would be 55 is across from side 7. So I'm going to say that the sine of the angle on top over the side across from it. Now I just need to do that again with a different pair of numbers. I'm trying to find side G, and it is across from angle 17. So those two are going to go together as well. So I'm going to say sine 17 degrees over length G. Now that I've got my problem set up, I'd probably get a point for that, probably get a point for drawing the triangle accurately, and now we're going to cross multiply to solve. When you cross multiply, you're simply going to just multiply the number on the bottom by whatever sign is that you've got, and you're going to do that twice. Now it doesn't really matter which pair you start with. Most of the time I see kids trying to use the variable on the left-hand side. That's where students are most comfortable, so that's what we're going to do here. Now we need to do G times the sine of 55. If we do the sine of 55 and then do the times G here, it's very unclear what the order of operations would be. Should you multiply the 55 and the G together first and then take the sine, or did you intend to take the sine of only the 55 and then multiply by the G later? Since that is unclear, it's good practice to simply put the bottom number, or in this case the G, in front of the sine, and now that clears up the issue. Now we don't need to worry about what comes first. Clearly we're doing the sine of 55 times something else. So that's what I meant by putting the bottom number in front of the sine when you cross multiply. It just eliminates confusion. Now we need to do the other pair, keeping the equal sign where it was. Now we do 7 times sine 17, making sure to put the 7 in front of the sine. So now we've got an equation we can solve. That equation needs to be solved for G. Currently that G is being multiplied by sine 55, so if I divide by sine 55 on both sides, then I'll be able to cancel sine 55 out on this side, giving me the value for G. Most students, I think, are fairly comfortable with that explanation and have caught on pretty quickly. The part that is trickiest is typing it in on the calculator correctly. So I want you to grab your calculator right now, making sure that it's in degree mode. I don't any longer have an online calculator that I can use to show you, so you'll just have to listen to the commands here. You'll have to type in 7 sine 17 and hit enter, then hit the divide key, and your calculator will most likely say ANS and then the divide. That's okay, that's good, that's what you want it to say. And then you type in the sine 55, then hit enter again. And when you do that, if you round to the 10th there, you'd get about 2.5. Let's see if we think that that answer is reasonable. Side 55 is across from a length of 7, and we're dealing with now a side length that's across from a much smaller angle. So we should get a smaller length than the other length that's given. So 2.5 is a reasonable answer. So that's the law of sines. Let's try another one. This one's a word problem, and you will run into some word problems in the rest of the chapter. So let's read what it says here. Two forest rangers are in their stations called S and T, and the ranger stations are 30 miles apart. On a certain day, the ranger at station S sees a fire at point F at an angle of 38 degrees, and the ranger at T sees the same fire at a different angle of 64. Find the distance from station T to the fire. Long ago, they paid forest rangers to sit and sleep in these very tall fire towers, is what they called them, and they were built tall enough so that they were above the tree line in forests. And some of these fire towers still exist. If you go to some of our national parks or state parks here in Minnesota, there are still a few of these available for people to climb up and view. So these do exist, although we don't use them to spot fires any longer. Now they're just more historical in nature. But what you see here is that it's very clear that a triangle has been formed, and so the two spotters are now able to pinpoint exactly where that fire is located. And we're going to use the law of sines to figure out the distance that they asked us for. So the picture's there. We need to go ahead and attempt to find angles and sides that are across from each other. So right away I can see that 38 and S are across from each other. Simply for correctness sake, I'm going to change that S to an X. Sometimes my S's look like 5s, and I don't want that to be confusing both on the notes and on the video. So 38 will be across from the missing side length, which I've now changed to X. Then the measurement of 30 is across from an angle that we don't know. We need to figure out what that angle measure is. So here we're going to have to use our geometry skills to figure out the missing angle, angle F. We know two of the angles in the triangle. One's 38 and one is 64. All the angles in a triangle, hopefully you remember from geometry, are equal to 180. So to find the missing angle, you simply subtract the two given angles from 180. And when you do that, I believe you get 78. So now that we have the angle that we need, we're going to go ahead and set up law of sines. So I'm going to say sine of 78 over the side across from it, and then sine of 38 over the side we're trying to find. Keep in mind that if you put this one first and then put this one after it, that's still okay. So if you flip-flopped your fractions, it's still going to give you the right answer. We're going to go ahead now and cross multiply. I'm not going to draw the circles this time. Hopefully you can visually track how to cross multiply there. So we get x sine 78 equals 30 sine 38. To get x alone, I'm going to divide both sides by sine 78. And I grab my calculator, making sure it's in degree mode. I type in the top and hit enter, and then I divide by the bottom. And when I calculate there, I get about 19. This is a word problem, so make sure you label it. We're measuring here in miles. The next thing that I'd like students to attempt here is something called set up the problem. I've given you 4 triangles here, and they are all needing to be set up with the law of sines. So I'd like you to set them up on your own, keeping in mind that some of these are a little bit hard to read, and for that I apologize. This angle here is 109. This one here is 34. This one up here is 74, and the side length here that got cut off from the screen should be side length 13. Go ahead and set those up on your own. Pause the video and the answers will be displayed shortly. When you set up the problems here, keep in mind that your fractions could be flip-flopped. So if you had sine 38 over 4.2 listed first, and then this one listed second, that would still be correct. So same thing here, if these fractions were flip-flopped, you'd still have the right answer. These last two here, you do need to do a little calculating to find the missing angle. Here we needed a sine of 72, here we needed a sine of 83. If you'd like to go ahead and solve each of these, you can go ahead and do that next, and I'll post the answers for those at the end of the video. But I would like to do this second problem with you here because it's got a missing angle. And we hadn't done an example yet of how to do a law of sines problem when the angle is missing. So let's go ahead and cross multiply here to solve. So I'm going to do 12 sine theta equals 8 sine 109. And just like all the other ones that we've done, the next step is to divide, but this time we're not going to divide by the sine, we're going to leave the sine there because that goes with theta. Over here you're going to type in the top and hit enter and then divide just like all the other ones that we've done. And when you do that you get a number that's about 0.63. Now be real careful on your calculator here, you do not want to do the inverse sign of just this decimal. The decimal on your calculator continues even beyond what the screen shows you. So when you do an inverse sign now to get theta alone, you're going to do inverse sign and then on your calculator do a second and then the negative key. And your calculator will say sine inverse and then it'll say ANS, which stands for previous answer. And if you need assistance with that, of course your teacher can help you during class on a one-on-one basis. When you type in inverse sign of that decimal, you get about 39, and it is in degrees. Now remember when we first started this lesson today, we talked about how doing an inverse sign can potentially have two answers. Do you remember what that second answer would be? Second answer could potentially be 180 minus the answer that we just got. When we do that, we get the number 141. So remember that that's this angle here. If that angle was 39 or 141, let's talk about what we think about that. This angle here is already 109. Could this angle be an additional 144? Hopefully you'd say no there. So in this case, we want to find that second answer, but then we're going to say, you know what, that second answer won't work in this case because the other angle that I'm given makes it too big. So this one only has one result. The next thing that I'd like you to try, after you've solved the remaining 3 problems for the missing side, I want you to try these 4 problems where you spot the error. So go ahead and give these 4 a try. There's a mistake or 2 or 3 made in each of these. Go ahead and correct the problem. Pause the video and give that a try. And so you can see here that the x and the 16 need to be flip-flopped. Here the angle that was chosen was incorrect. X and 17 are not across from each other. The third one has all kinds of problems. All the 15s and the 16s are in the wrong location. And then over here again we grabbed the wrong angle measure. And finally I said that I would show the answers for the spot the error questions. If you went ahead and solved those, you should have gotten 7 for the first one, 55 for the third one, and 31 for the last one. And if you have any questions on those, feel free to ask your teacher during class.